Hi, good morning, everybody. My name is Adanlawo, and I'm a DevOps engineer at Demos Cloud. Today, I'm going to be talking to you about deploying microservices on Kubernetes at scale. First, let's go through a brief recap on Kubernetes. I'm sure some of you have heard of the word Kubernetes. Some of you work with it on a daily basis, while some of you are just wondering what's Kubernetes. I got all of you covered, so this is the official definition of Kubernetes, right, from their blog, from their documentation. It says Kubernetes is an open source container orchestration system for automating deployments, scaling, and management of containerized applications. Now, if I was a total beginner and you told me all of this, I'm sure I'll be as confused as some people might be. So I'm just going to try as much as I can to break this down, right? So before I explain like what every word here means, I would there is this definition that resonates with me. Is a definition I call it the 5-year-old definition. I think I read it somewhere, one blog, one time. I can't remember, but it's a 5-year-old definition, right? Like explaining Kubernetes to someone like they're five. So let me paint a scenario. Say you have a cow business, right? You buy and sell cows, you produce cows if that was possible. You produce cows and you buy and sell them, right? You manage these cows. So let's say you have this template, this blueprint that you always use whenever you want to make cows. So it's already there, the blueprint is already there. Whenever you want to make a cow, you just take this blueprint and replicate it across as many cows as you want to make. Do you get? Now, so let's say your business is growing and you have this template, right? You replicate it into as many cows as you want. Say 500 cows. You just take this template, run it through a system, and it gives you 500 cows, right? Then your cows are getting plenty. Like you now have maybe millions of cows, 500 million cows now, and you're looking for how to manage these cows. So you have a ranch. I'm sure you guys know what a ranch is, like as per Obudukato Ranch. So you have a ranch now, and inside this very big ranch, you have smaller ranches that can maintain and manage like a few number of cows. Say you have this big ranch A, or no, say you just have this big ranch, and then inside this big ranch, you have like three other smaller ranches, say A, B, C. You have three ranches A, B, C. Now, you need a way to manage those cows and put them in A, B, C. So you employ somebody, right, that can help you do it. And this person is called a rancher. Lack of a better word. This person is called a rancher. So this rancher now is in charge of taking those cows and you tell them. So you as the owner of the cow factory or the cow business, you know how many ranches you have. So when this rancher comes now, you tell this rancher, oh, I have ranches A, B, and C, and I need you to maintain ranches A, B, and C for me. I need you to keep these cows and ensure that they are fine in ranches A, B, and C, right? So after telling the rancher that, then you give the rancher the cows. Now the rancher goes to those places and check, oh, okay, is there enough food for if I put 200 cows in ranch A, do I have enough food, enough resources to cater for these 200 cows? Okay, so if he says, oh, 200 cows enough, I put 200 cows in ranch A, same in ranch B and ranch C like that, and I spread the cows around like that, yeah. And so as the rancher, my job is to go back there to check, right? To check, oh, how is this doing? How are these cows doing? Now, at some point, the cows grow bigger, right? As they feed, they grow bigger. And then you see that, this 200 cows is becoming too small. Like the ranch size is becoming too small for 200 cows. Now, you have two options. It's either you increase the size of the ranch, if that's possible, or you take out some cows to leave some more cows in. That's just the definition of Kubernetes. So let me explain. The template that you have could be your Docker image. Could be your Docker image that you want to use to create more cows. So your application, you already have a Docker image, right? and that Docker image, use it to create more cows. Now those cows that you create are your containers. They are your Docker containers from that single image. You create, say, 500 containers, right? So you create um so many containers, then that rancher, the person that you employ to help you manage those cows across those ranches, is Kubernetes. Those ranches that you have are the nodes, they are the Kubernetes nodes. So Kubernetes now goes and manages your application. That's the Docker containers. That's why they call it a container, that it manages containerized applications, because now your Docker containers, you have 500 Docker containers, and Kubernetes manages them for you, right? It goes and knows that, oh, this node is already full. I need to auto scale. I need to scale these nodes to accommodate the way these cows are growing bigger, or I need to take out some pods from this node and move it to another node. That's what Kubernetes does for you. It's a manager. It manages your applications, your containerized applications, right? And I'm guessing some people have an idea of what Docker is and how it's used. That's not the focus of this talk for today. But if you don't, it would be nice for you to have an idea of what Docker is, so you can understand this better. But I hope my 5-year-old analogy has helped somebody, right? So next there is this link here that I have. So this link is like a comic representation of Kubernetes and microservices, and would help you understand too. So if you still don't get the analogy I just gave and you still want to like have a deeper look, this would help. So I'm sure now by the time you go through this and you try to understand what I just explained, it will make sense when I say Kubernetes is an open source container orchestration system for automating deployments, scaling, and management of containerized resources. Now that's Kubernetes. It's a lot of, you get millions of definitions of it, but long and short, that's what Kubernetes is. Now, so these are Kubernetes features, right? We have declarative configuration. Let me take it one at a time. So declarative configuration here is the way Kubernetes works is I give Kubernetes what I want. I come and say, oh, I want Kubernetes to do XYZ for me. I put that XYZ into a configuration file, which could be YAML or JSON. I put that specification that I want into that YAML file, and that's exactly what Kubernetes is going to give me. It's not going to take away anything from it. It's not going to add anything from it, right? Kubernetes give me exactly what I want. That's why it's called a declarative configuration. So it helps your version control systems. I can have my configuration files in the same repository that I have my code or I have my application, and Kubernetes still works very well for me. So anywhere that code goes, I still have my configuration files, and it's easy for me to replicate. Do you get? So that's declarative configuration. We have horizontal auto scaling. Now this should be auto scaling in general, because Kubernetes can scale either horizontally or vertically, right? But horizontal in this case is, say I have two nodes. I want to make it three. That's horizontal auto scaling. Vertical is, oh, I have two CPU cores inside one node. So instead of me to make that one node two nodes, I want to increase the CPU cores. That's vertical, right? And you get the gist. Then we have immutable infrastructure. Immutable infrastructure is where I deploy an application and I deploy. So let's say I have a server, right? And okay, let's say I deploy an application and I want to make changes to to that application. Pardon me. I want to make changes to the application. Now with immutable infrastructure, I I cannot go and modify that already deployed infrastructure. I have to, like, it has to update, like remove this and replace it. That's what Kubernetes is. It cannot go and patch your system for you. It would rather remove it and spin up a new one, right? Self-healing systems. So if your pods are going down, Kubernetes just as a way of trying to fix things for you. It's just like all around. This list is not exhaustive. This is just like for you to have an idea of what Kubernetes does. And decoupled architecture. So it's like it has the different parts separate and they communicate over well-defined APIs. right? It's more like a microservice architecture. So it just has everything separated like that, and then they just communicate over well-defined APIs. That's all. And those are like the main features of Kubernetes that I think you need to know for the purpose of this talk. So now that's the brief recap on Kubernetes. Let's move into microservices. I'm sure some of you have built microservices before. I'm sure so many more of you have worked with microservices, but even if you haven't, I'm going to do a brief recap on microservices too, just so that you can have an idea and you'll be able to follow through this talk. Microservices, also known as the microservice architecture, is a style that structures an application as a collection of services that are highly maintainable and testable, loosely coupled, independently deployable, organized around business capabilities, and owned by a small team. That feels like a lot to take in again, right? Highly maintainable and testable, loosely coupled, independently deployable, organized around business capabilities, and owned by a small team. I have another analogy. Let me share. So I feel like, sorry if you feel I'm sharing too many analogies, it's just what helps me understand and what helps me explain to people in a way that it is clear, right? So a perfect analogy will be, I have a very big store, right? I have a very big store, and in this my store, I sell everything you can think of. I sell yam, I sell furniture, I sell what else can I sell? I sell water, I sell food. So let's say I just have so many things that are not totally related. I sell them in this my very big store, right? And um so the way the store is built is such that as I have everything in the store, if I want to make any change to the store, maybe I want to upgrade the section, maybe the yam section, right? We're in raining season. Okay, I think yam comes out in rainy season. We're in the raining season, and there are more yams. So I want to like expand the yam section so that it can take in more yams, right? And I do that. I want to expand the yam section. But because of the way the store is, for me to expand the yam section, invariably I have to expand every other section, or that expansion process is going to affect every other section of the store. Now, that is not sustainable. It is not in any way sustainable, because why do I have to expand just the yam section and I end up expanding the cars section? Like, there is no relationship between the cars and the yam. I should be able to do them separately. Now, that is where microservices come in. Now, microservices is okay. So I have this big store. Just, and by the way, that's what I just explained is the monolith architecture. The way applications were built in past times. That's the way old applications are built. Everything is just mobbled up into one main store. Let me call it a store. Everything is mobbled up into this store, and if you're going to upgrade any part, any aspect of the store, you end up touching every other part, or that single upgrade affects every other part. Now, that was where microservices came to the rescue. Now, microservices is such that I have these different applications. Say, let's still use the store analogy. So I have the car section as a different entity, and it is right there. I have the yam section, a different entity is right there. I have potato section separate. I have the food section separate. So even if I have to make any update to any of these stores, any of these sections, I can always do that without affecting every other part because they are separated. Meanwhile, they might still be inside the same store. Even though they are inside the same store, the fact that they are separated means that I can touch this part without affecting that part. So it just means that the part that I'm touching might be down, or might be the one experiencing all the changes while the other parts are working fine. That's just what microservices are. You want to build an application, you have your authentication separate, you have your what other thing? You just have all those different applications separate like that, so that they are loosely coupled. So now you see, highly maintainable and testable. You build them such that just the standalone application is good to go or is good enough, right? They are loosely coupled, they are separated, right? And they can communicate. So there is a communication between them that goes between them. So even though they are separated, they are still part of one main body and they can communicate, right? Independently deployable. I can deploy the authentication section separate from deploying the what's it called? The checkout section. I can just deploy them separately and they will still communicate. Organized around business capabilities and owned by a small team. Owned by a small team because a small team has to manage all those tiny, 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 tiny applications. A small team has to manage them. Yes, microservices has its own downsides, but I feel like the benefits are more. They are better than the downsides. They are greater than the downsides. So let's just move. Um, so this is just like a drawing I got online from a Medium profile. You see the monolith architecture that I just explained. Everything is just mobbled up into one space, and any update affects everywhere else. Now we have this other one, this other side where you have the UI and it communicates with all these different microservices like that, as you can see. I'm sure this explains it better. So that's that about microservices. So now, microservices and Kubernetes, how do they relate? What is the relationship between these two? What good can these two give us, right? Then we have containers. Remember when I was explaining Kubernetes, I said it works with containerized applications. Now just let's recap and like link it. So you have Kubernetes deploying in containers, like you have your containerized applications and Kubernetes manages it for you. Now you have this architecture structure that deploys small applications like that for you. And you can just deploy those small applications on Kubernetes and you just have all the goodness in the world. Right? So let me just explain what containers are, right? Containers are immutable. I'm sure you know what immutable is now, by the way. Like you can't make updates to them, you have to like replace them. They are immutable, they are lightweight, they are ready to run software packages that contain everything needed to run the application, which includes the code, dependencies, libraries, etc. So let's say you have this container, your template or your blueprint in code. You have this container, and this container let's say this container contains, but this container has everything you need to deploy your microservice. Say this container has everything you need to deploy your authentication service, for instance. I think that makes sense. So you just have everything, and then if anything happens and you need to deploy your authentication service, you just go to your container, your authentication container, and boom, you just pick it up and you deploy it, and everybody's happy. Everybody can go to bed, right? So containers are the link between microservices and Kubernetes. Definitely, containers are the link between anything and Kubernetes, right? Because Kubernetes manages containerized applications. But in this case, just think about it a little more. Microservices, all the goodness it has, and Kubernetes, all the goodness it has. Well, before businesses or applications deploy microservices, there are some things they always consider. Scalability, which is like our major focus for today. Scalability, I want to be able to make changes to this application without affecting every other thing. Like how fast can this application react to more okay, say go back to the store analogy. More people want to buy yam. There are more people that are coming. How fast can this section react to accommodate the more people that are coming and possibly shrink when we have less people? Okay, say I have the yam section now and I see that, oh, many people are coming to buy yam. Can I borrow from the potato section, like just join it together to sell my yam, because now I have more yams and I have more people trying to buy yams? And then probably when we go back, when we leave the yam season and yam is not so much in request, can I go back to the size I was, the small section that I was? That's what scalability is all about, right? So it's part of the factors. It's like a major factor that is always considered when we deploy microservices. Scalability, application availability. Remember I said that they are like small sections. It won't be good now that in your store the yam section is not working, and the yam section is like, okay, no, maybe not yam section, the checkout section, the part where people pay, is not working, And then so everybody else that buys everything in the store, they are stranded because they can't pay, they can't check out because your checkout section is not working. So even though they are separate applications, they still have to be available. If not, they might cost you a lot of money, right? Your applications have to be available. They are manageable and they are secure. Same thing, the fact that they are separate applications does not mean that you can cook beans inside. Pardon my lingo. Does not mean that you can cook beans inside and just leave it like that. It has to be secure. But thankfully, Kubernetes achieves, maybe not all, but a majority of it. That's the scalability, availability, and all of that. Kubernetes helps achieve that, right? So now the problem. Now I've said a lot of good things about about this Kubernetes and microservices. I've said a lot of good things, but definitely there will be problems, right? Now the problem with that is actually in the way people deploy microservices to Kubernetes. That's where the problem is. Not because it doesn't give you so much goodness. It's just because people don't. Okay, let me not say they don't know how to. They just probably don't have a better way to, or they don't know a better way, which I know, and I'm trying to tell you today. So, however, before now, developers and operators alike deploy microservices to Kubernetes by writing and deploying manifests manually for microservices that are very similar. Say yam and potato section, they are very similar, but you have their Kubernetes manifest. Remember, I said that Kubernetes deals with declarative configuration. So I have that declarative configuration for each and every section like that. It becomes tedious. Like, we're already using Kubernetes. Kubernetes comes with a lot of automation, and then we still have to do a lot of manual processes, right? It doesn't just gel. So if we're already using Kubernetes, why not just find a way to just, automate everything and, you know. So imagine writing those manifest files. It's called manifest, by the way. Imagine writing those manifests for all the applications. Before you know, these things become modeled up and they are not maintainable, right? So like I said, this isn't sustainable and cannot scale because you'll keep building more similar applications, right? It won't scale. That's just the truth. So now it's a big problem. I've seen it happen over time, and I have a solution, which is what I'm going to share today. So, introducing Helm. Now, Helm is not the end itself, but it's a means to the end. If that makes sense. But Helm. Now, what is Helm? Helm is a package manager for Kubernetes that allows developers and operators easily package, configure, and deploy applications to Kubernetes clusters. Helm is built with Kubernetes in mind. Like, you can't use Helm for anything aside Kubernetes. So if you are a Node developer or a JavaScript developer, you know what npm is. You know what yarn is. Those are package managers. Same is Helm. So Helm is to Kubernetes what npm and yarn are to their different languages. Simple as that. So don't overthink it. Package manager for Kubernetes. It allows developers and operators easily package, configure, and deploy applications to Kubernetes. So imagine your already smooth process of deploying applications to Kubernetes, and then there is now something that can even make that already smooth process even smoother. That's what Helm is, right? So now, like I said initially, Helm is not even the end itself. It's a means to an end. Now, that end is Helm charts, and that is like the beautiful. That is what this entire talk is hinged upon. Helm charts. So Helm charts are packaging formats used in Helm. They are a collection of files that describe a related set of Kubernetes resources. Emphasis on a related set of Kubernetes resources. A single chart might be used, one Helm chart can be used to deploy something simple, like I can have an Helm chart to deploy Redis pod, or I can have an Helm chart to deploy a full web app stack with HTTP servers, databases, caches, and so on. So a Helm chart can go for 0 to 100, whichever way you want it to. Like, it is that flexible. If you want it to just give you A, to give you A. If you want it to give you A to Z, it will give you A to Z, depending on how you configure it. That's what Helm charts are. So Helm charts are packaging formats used in Helm. They are a collection of files that describe a related set of Kubernetes resources. I don't know if you understand that. I don't have a a 5 year old analogy for this one. Sorry, but I just hope you have an idea. Like, so let's say I have Helm chart. I have um. Okay, let's just continue. I'm sure you have an idea by the time I continue. So this is the official Helm chart repository. Okay, maybe not. It's still a repository. This is the official chart repository. So in this link here, there are several charts that people have built. Same way with npm. Like you just have all the npm that people have built in this world that are published to Helm. By the way, published to Helm. You have everything in this beautiful link, and yet if you want a Redis, you don't have to like reinvent the wheel every single time. You can always just go here and pick a chart that works for what you need it to and just run with it. Simple as ABC. That's this link. That's why I have it here. But we're going to create our Helm chart um, to streamline our deployment process. We want to tailor it to meet our needs, to suit our needs, right? It's very simple. Once you have all the dependencies, this is not a full tutorial on how to use Helm charts or how to create Helm charts, right? So I'm not going to go into all those details, but if you want to create an Helm chart after having Helm installed and kubectl and all of that, it's as simple as Helm creates chart name. So let's say you want to call your chart name Lego. I don't know what that word is, but you want to call your chart name Lego, or you want to, maybe your application is called Lego, right? And you want to create a chart for Lego application, right? Just do Helm create Lego, and it gives you a template that you can work with any day, anytime. The template, of course, you now have to tailor this template to suit your needs, but it like helps you from the ground up. I don't know if you dig. So let's just go. When you do Lego application, so it starts with your Lego here, and it gives you all these files. Now I separated them by important to least important. Not like least important, but you get the gist. So the main ones that you might need to touch or you might need to make changes to are the chart.yaml, which is where it shows you information about the chart. The values.yaml, very important, because that's where the default configuration values for the chart are going to be. Then this chart directory, if you have if your own chart that you want to create, for instance, uses Redis or Postgres, they are going to be in this chart directory because they are dependencies for your chart to function. Then template. Now it is inside that template that you're going to have all your declarative configuration that you want your chart to deploy for you. Everything is going to be inside this template folder. Like I said, a directory of templates that when combined with the values will generate valid Kubernetes manifest files. Now they are written in template language. So everything, so if I want to have ingress services, those are Kubernetes lingo, right? If I want to have all of those manifests, right? I put them in my templates file. I think the templates comes with a few manifests already. Then it picks those values. So it is dynamic. Once I set a value in my values.yaml file, it is picked by everything in the templates file, and that's all. And you just build. Once you just configure your values.yaml file to have the right values per the different applications you want, you are good to go, basically. So yeah, like I'm just going to major on two parts that I feel are very important, which is the templates directory. I've already talked on it, by the way, which is the templates directory and the values.yaml file. So firstly, the templates directory. I said this is the number one most important piece of the puzzle because this is where the entire customization happens. Everything you need to deploy your Kubernetes application is going to be in this templates file. All your declarative configuration files are going to be in this template file, right? So like I said, all Kubernetes manifests to be deployed by the project are set here. The manifests are written in template language to be picked up and rendered by Helm through a Go template engine, pardon me. So Helm is using a Go template engine to pick up everything you've written in your templates language. Sorry. to pick up everything you've written in this template directory in the template language and deploy it. Now, this works with the values.yaml file, because the values.yaml file, like I had previously explained, will provide metadata about the chart and inputs for the Kubernetes manifest. The customization per project is set and overwritten here. For the different projects, this chart will be used to deploy. Let me give you a small explanation. So, I have this big Helm chart, right? I have this Helm chart that does every single thing that I need for me. So this Helm chart takes away the hustle of me writing individual manifest file per application in my version control, because it's not sustainable, right? So once I have this big Helm chart that has everything I need, all the manifest I need rather, it has it inside this templates directory. The only thing that will change per application is the values file, which is where the customization happens. So let's say I have a project. My project A needs Kubernetes resource um, WXYZ, right? WXYZ. Now, project B might not need W and Y. It might only need X and Z. It is in my values.yaml file that I can say, okay, you know what? Let's take out W, let's take out Y, and leave X and Z that project B needs. So my Helm chart is reusable across as many projects as it suits the specification. So the fact that you have 10 manifest files in your templates directory does not mean that you have to deploy all 10 manifests. Now, because it's written in template language, it is, a lot of curly braces and all of that. But if you look at it deeply and maybe a few tutorials, it's something you can easily pick and understand. Like it's not hard at all. So that's just there's probably a learning curve, but you see, once you master the learning curve, like everything is fine. Like you are chopping life, basically. Like it's just like that. So the values.yaml file, it just makes your life easy. Like it just makes everything sweet and it lets it gel. Um, like I said, this is like the main focus of this talk, Helm charts. A lot of people, a lot of people don't maximize this. I don't know why, but at Demos where I work, at Demos we use Helm charts for like everything. We have this very gigantic Helm chart that one of my colleagues like single-handedly built, right? He worked on it, he did a perfect job. Now this Helm chart is we keep making changes as new projects arise, like we keep making considerations for new projects and we keep adding all of that. But you see this Helm chart, it has your deployment file, it has the ingress file. We just pick the values file and set it for the different applications and we publish it and everybody goes home happy. Like instead of having to write deployment file inside the version control, this file inside version control, that file inside version control. Like it just helps. It just makes life easy, right? So that's like, I just want to implore a couple of people. If you have interest, just learn it and just see the magic. It brings a lot of magic to your microservices and your Kubernetes. you know it brings a lot of magic to it. You really won't know how it helps you automate. It helps you scale. It helps you scale because you don't have to reinvent the wheel every single time. Like I can't emphasize it enough. It helps you scale. Right. So this is not our focus for today, but I'm just going to touch on it because it is easy. So another thing that would help with scalability, even if you have all the most beautiful Helm charts in the world, and you have the perfect Kubernetes cluster, and you have built your microservices to scale, blah blah blah, you have everything. Automation with CI/CD is like that. Is like the cherry on the cake. Yeah, something like that. It's like the cherry on the cake. I'm not going to focus more on it, but I'm just going to like, manual Kubernetes deployments are error prone. Fine, you have your Helm chart that does all the magic for you, but it doesn't change the fact that they're still error prone when you have to go there manually and install the chart for the different applications. They're error prone. Now, CI/CD, continuous integration deployment, are practices that make preparing a software release easier. So imagine you finish building this application now, this your microservice now. and you want to push it out. You already have the Helm chart, but now you have to manually go and make those changes. Probably there are other things you need to deploy to aside the Helm chart, and it's just tedious going to do all those things manually. Meanwhile, you can have a CI/CD pipeline that just runs everything for you. So if you need to deploy 100 times in a day, you can just it's just like clicking a button, running your CI/CD pipeline, and everybody's fine, right? As opposed to you manually going there to set it up every single time, right? It's just an automation. It's not the focus for today, but just so that many people can embrace it. Like I said, CI/CD automates the building, testing, integration, and deployment phase. It just makes it easy and sustainable. Now, there are a lot of CI/CD tools that you might come across. There is Jenkins, which I like. There is GitLab CI, which I love. There is Pinnacle, which I have an idea of, but I've not worked with well. There is Travis CI. There are a lot more. So you might have to check one or two before you finally find one that you settle with. I won't tell you which one I've settled with, by the way, but you would find one or two that you like and you want to settle with. You get there are a lot, so you are not just check it out and you know. But CICD just makes your life easy. Like all these things we have been saying since the morning, CICD is like the icing on the cake. Then, in conclusion, customized Helm charts make the already simplified deployment process with Kubernetes way easier to manage, hence making deployments with Kubernetes scalable. Now, we agree this saves time and effort as opposed to running individual manifests per project. Right? That's my closing remark. Nothing more. So, thank you so much for listening to my talk. Thank you for because I know you're going to take a few of these things and incorporate them into your day to day. That's if you do this on a full scale into your day to day cycle. And please follow me Twitter, check my GitHub, and I write in this link right here, pavecloudgirl.ashno.dev. So I write a couple of tutorials there. So I might still do a full tutorial on this, right? But just check it out. Just and maybe just keep just follow me to know when I probably drop a tutorial on this. Thank you so much for your time and see you later. Bye.